I'm Don MACHHOLZ, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 47, for the week of November 25th, 2020. The related website for this podcast is donmachholz.com. That is spelled DonMachHolz.com. What's up in the sky this week? As our week begins on Wednesday, November 25th, the moon is a gibbous phase high in the east in the evening sky. Gibbous is between half and full, and between full and half. The moon will be just south of the planet Mars on the evening of Wednesday, November 25th. Full moon is early on Monday, November 30th, when there will be an eclipse. More about that later. By next Tuesday, the moon will be rising a couple hours after sunset, but will still dominate the evening sky. Whenever the moon is up, take some time to look at it. As we would often hear at our public star parties, "Wow, I can even see the craters." The moon would often be our second most favorite object at star parties, with Saturn being first, the moon being second, and Jupiter third. If you want to study the moon more, use some of the books and atlases and online sources to learn your way around. Or join the Association of Lunar and Planetary Observers, known as ALPO, ALPO, and receive each month the ALPO Lunar Digest. Speaking of first and third, Saturn and Jupiter hang in our southwestern sky these evenings, creeping towards the sun and creeping towards each other. Creepy. By the end of December, these planets will be lost in the solar glare, only to emerge again in late February, early March 2021 in our morning sky. So now is the time to see them. Look at these two gas giants, the rings of Saturn, its moons, and look for spots on the ball of the planet. On Jupiter, look at its moons. Can you tell which is which by appearance? Look also at the bands of Jupiter and for its red spot. Mars is still putting on a pretty good show high in the sky each night. The advantage of it being so high in the sky, there's less atmospheric distortion. The more you look, the more you'll see. Question of this week is there a new dust storm starting on Mars? There will be a penumbral lunar eclipse on the night of Sunday, Monday, November 29th and 30th. For 4 hours and 20 minutes, the moon will be in the outer shadow that the Earth cast into space. This is not a total lunar eclipse, where the moon travels through the midsection of the Earth's shadow and gets dark with a red or orange hue. This time the moon avoids the Earth's inner shadow. As a result, the moon, while at full phase, will get a bit darker than normal. You will see some grayness on the moon. The shadow will be darkest in the north portion of the moon, and during those 4 hours and 20 minutes, the shadow will slowly move from the east to the west side of the moon, again staying on mostly the north half of the moon. Those who are familiar with the moon will notice that it does look different, especially at the time of mid-eclipse, also known as maximum eclipse. There will be some grayness to the moon. It won't be the super bright full moon. You might say to someone, "Does that moon look funny to you, or is it just me?" When you have a lunar eclipse, everyone who can see the moon can see the eclipse. So that's like half the Earth. And as the Earth rotates during those 4 hours and 20 minutes, more than half the Earth can see at least part of the eclipse. This time, Sunday, November 29th and Monday, November 30th, at least part of the eclipse is visible in Greenland, the Atlantic Ocean, the Arctic, North America, South America, Pacific Ocean, Australia, New Zealand, Hawaii, and Indonesia, Asia, the Scandinavian countries, and Great Britain. In some areas, the moon will be setting before the eclipse ends, or rising after the eclipse begins. The moon will be setting in the eastern areas that I mentioned and rising in the western areas. Who will see all of the eclipse? That is, it will be above the horizon for all 4+ hours. Greenland, all of North America, the Pacific Ocean, Eastern Asia, and most of Japan. The middle of the eclipse, when it is at maximum, will be on Monday, November 30th at 0943 Universal Time. In the United States, this translates to Eastern Standard Time of 4:43, Central Standard Time of 3:43, Mountain Standard Time of 2:43, and Pacific Standard Time of 1:43. That's the time of the maximum eclipse. To calculate when the eclipse will start, subtract 2 hours and 11 minutes. To calculate when it will end, add 2 hours and 10 minutes to the maximum eclipse time. So the beginning and end times for Eastern Standard Time is from 2:32 to 6:53. For Pacific times, the start and finish times are 11:32 p.m. on Sunday evening, November 29th, and it ends 4 hours and 20 minutes later at 3:53 a.m. on the 30th. Most of the shadow of the Earth will be on the north part of the moon, but the shadow will slowly sweep across from the eastern to the western portion of the moon. Will you be able to see the International Space Station this week, which for our purposes begins on Wednesday, November 25th through Tuesday, December 1st? It all depends upon your location. This week we have 6 zones. All you need to know is your latitude. From 37 through 60 degrees north, the ISS will be in your evening sky all week long, sometimes twice per night. From 10 degrees south through 37 degrees north, you won't be able to see it at all this week. From 30 degrees to 10 degrees south, you will see the ISS in your morning sky, but only for the first part of the week. From 40 to 30 degrees south, the ISS will be in your morning sky all week long. From 50 to 40 degrees south, the ISS will be in your morning sky, but only for the second half of the week. And south of 50 degrees south, you won't be able to see it at all this week. To determine where it will be in your sky, go to the website heavens-above.com and enter your location. Then click on the ISS. Now for the comets you can see this week. The positions, that is the right ascension and declination of these comets, can be found on Podcast 41, Comet Positions. You can also get the positions of these comets from the website heavens-above.com. Comet Howell 88P is magnitude 9.5 and southeast of Jupiter and Saturn. You might want to wait until the moon gets out of the evening sky early next week before you look at it. It is plotted on Podcast 47, Map 1. Now up nearly all night long is Comet 2020 M3 Atlas. It's in the constellation Taurus, and it passes 2 degrees west of the Crab Nebula M1 on November 27th. You might want to wait until moonset in the morning hours to see this one well, as Comet Atlas is large and diffuse and difficult to see in light-polluted skies. You will find it plotted on podcast 47, maps 1 and 2. Our brightest comet at magnitude 7 is Comet C 2020 S3 Erasmus. It is low in the pre-dawn morning eastern sky, headed towards the solar vicinity. It is plotted on podcast 47, map 2. We have not had any feature objects in the past few weeks, as we've been going through the book, A Decade of Comets, but now we are back. And with a bright moon in the sky, we'll examine a double star system on the other part of the sky from where the moon is located. This week, our featured object is the star Delta Lyra. It is in the constellation Lyra, one of the 4 stars in the parallelogram south of the bright star Vega. It is a northeast star of this figure, and it's identified on podcast 47, maps 1 and 2. Also, podcast 47, map 3 is a detailed map and photograph of this star system. Delta is actually 2 stars. One is Delta 1 and the other is Delta 2. Guess which one is the brightest? No, it is Delta 2. Delta 2 is the brighter star. It is magnitude 4.2 to 4.3. Yes, it varies in brightness and in a regular manner. It is a large star, not very hot. It appears red, and if it were in the place of our sun, we would be inside of it. It is that big, and it is 900 light years away. We'll get back to Delta 2 in a minute. Delta 1 is the fainter star, magnitude 5.6 and 10.3 arc minutes away from Delta 2. This is more than 1/6 of a degree, and with the unaided eye it is well separated from the main star, but it is not very bright. Delta 1, a rapid rotating hot blue star, is 200 light years further away from us than Delta 2. So the system is not really connected. Give it a try though with the unaided eye, Delta 1 and Delta 2. Magnitudes 4.2 and 5.6, 10 arc minutes apart. With binoculars, you can see more of the Delta Lyra system. Give it a try. Use podcast 47, map 3 as a guide to this area. The Delta 2 star is the brighter one, red, and the Delta 1 star is blue. With the increased aperture over the unaided eye and being able to see fainter objects, both Delta 1 and Delta 2 should be easily visible. And now you might notice the colors, blue and red. There is also a faint star cluster associated with these stars. It is known as the Stephenson 1 cluster, named after Charles Stephenson, who first noticed this in the 1950s. This cluster is also known as the Delta Lyra cluster. It is about 20 arc minutes across and has about 30 members. Through the telescope, look for the 2 different colors, with the brighter one, Delta 2, being red and the fainter one being blue. With a telescope of at least a few inches aperture, you can see the companion to Delta 1. The companion of Delta 1 is magnitude 9.9 and 2.9 arc minutes to the north. That is a quarter of the distance to Delta 2. And Delta 2, the brighter one, it's a double star too. Its companion is 2 11th magnitude stars very close together. The combined light is equal to about magnitude 10. They are located 1.5 arc minutes north of Delta II. With a large telescope in good conditions, you might be able to split those 11th magnitude stars. They are 2.2 arc seconds apart. With the telescope, look also for the faint star cluster Stephenson 1. Again, about 20 arc minutes across with about 30 stars. All of these objects are identified in Podcast 47, Map 3. You have been listening to Looking Up with Don, podcast episode number 47 for November 25th, 2020. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ. You can contact me at dontheastronomer@gmail.com. Once again, that is dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky and highlight some specific objects to observe. All that and more. Thank you for listening. See the sky this week. I'll see you next week.